Hello everyone. So welcome back. So in the previous video, we discussed the questions from differentiability and continuity. So again, I am taking some questions, very important questions of differentiability. So let's start. I hope you have seen all those videos, and this question appeared in JEE Mains 2021. So the first question we are taking here is, if g is a function which is defined from 0 to 4 to r, and gx is defined by this maximum of this value, where t is between 0 and x is between 0 and 3, and 4 minus x if x is between 4 and 3, the number of points where the gx function is non-differentiable. Okay, so basically idea, you have to define this function gx. For that, you have to check what is the expression maximum of this if t is between x and 0. T is between 0 and x is between 0 and 3. Now, if you just observe first, let's talk about this thing. So let's say you have this function. I have a function f of t which is equal to t cube minus 6t square, okay, plus 9t minus 3. Okay. Now, first let's analyze this function. So how will you analyze a cubic equation? You can find the derivative. What is f dash t? This is equal to 3 t square minus 12t plus 9, or this is 3 t square minus 4t plus 3. This is f dash t. So you can say this is 3 times t minus 1 into t minus 3. So you can see here the graph of f of t, the graph of this function f. This is derivative is 0, f dash t is 0 at t is equal to 1 and 3. If you just check what are the values so that it is easy to plot, what is f of 1? If I put x is equal to 1 here, this is 1 minus 6 plus 9 minus 3. So you can check what is this value. This is 10 minus 9, which is equal to 1. And what is f of 3? If I put f of 3, this is 27. This is 27 minus 3, that is 9 into 6, 54. This is 9 into 3, that is 27 minus 1. So what is this value? This is cancelled. This is equal to minus 1. So we have got the value f of 1 and f of 3. Okay. So you can see here, the graph of f, graph of this function will be something like this. We are interested only in 0 to 3. That is why I'm just drawing graph in 0 to 3. This is 0, 1. The derivative at 1 is 0, and the value at 1 is equal to 1. You can see this is 1. And the derivative is 0 at minus at 3 also. So this is minus 1. This is derivative is equal to 1. Sorry, the function's value is equal to 1 and minus 1 at 3. Okay. So now the rough sketch, you can see at x equal to 0, what is the value at x equal to 0? Minus 3. So it will be something like this. It will start from minus 3. So it will go at 1. Derivative will be 0 at 1. Then derivative is 0 at 3, and the value at 3 is minus 1, and it will go something like this. This is the rough sketch. You can see between 0 and 3. 0 and 3 for this function. Okay. Now understand this. What we are saying here is, if x is between 0 and 3 and t is varying from 0 to x, what is the maximum value of this? If you just observe, for example, if you take any value of x between 0 and 1, for example, if you take the value of x is this, okay, this is the function y is equal to fx. Okay, this is the graph of y is equal to fx. Yeah, this is x, this is y. Now if I take, let's say this is the value of x, this is some value x. So if I take x is equal to a value less than between 0 and 1, you can see here the maximum value will be at this point only. You can see the maximum value of this function will be at this. If I take, let's say this is the value of x. So what is the maximum value from 0 to x? This is the maximum value from 0 to x. If I take this is x, then what is the maximum value from 0 to x? This is the maximum value here. So can I say this is gx will be equal to f of x. That is this thing, f of x, if x is between 0 and 1. 0, but this will be closed, right? And 1, we can write 1, right? Now as 1 pit is, you can take closed. Now as you cross 1, you can see, let's say this is the value of x. Now from 0 to x, what is the maximum value? Maximum value will be equal to 1, right? If you take, let's say this is x, so from 0 to x, what is the maximum value? Still this is 1. So you can clearly see till 3, if you take any value of x, 0 to that value, maximum value of this will be equal to 1. So what is this? This is 1 if x is between 3 and 1. Correct? Why I have taken equality here? You can take equality here also, because ultimately f of 1, the value at x equal to 1 will be equal to 1 from both the cases. So you put here or here, ultimately it will not affect. And so we have defined till this, and now the third is 4 minus x. This is equal to x is between 4 and 3. So this is the defining, this is how we can define this function gx. So now we have to check the differentiability of this function. So you can see here, if I write this gx function, what is gx function? This is equal to fx. So what is fx here? You can see fx is equal to x cube minus 6x square, x cube minus 6x square plus 9x minus, you can see 9x minus 3, 9x minus 3. This is 1, or this is 4 minus x. You can check this. We have defined this fx. What is fx? This is 1, 4 minus x, depending upon x between 0 and 1. This is x is between 3 and 1. This is x is between this is x is between 3 and 4. This is between 3 and 4. So this is the expression we have. Correct? Now we have to find that at which points this is at which point this function is non-differentiable. This is non-differentiable at which point? This is, now how will you check the differentiability? You can clearly see these functions are, you can say this is a differentiable function, this is a differentiable function, this is a differentiable function, except we have to check at end points. Baaki sab polynomial hai, the polynomials are always differentiable function. Now you see here, what is limit x approaches 1 plus? Limit x approaches 1 plus, this is equal to, what is limit x approaches 1 plus? This is equal to 1. Gx ka limit, this is 1. You can see x1 plus, this is 1. What is limit x approaches 1 minus? So 1 minus पे we have this function, हमने already check किया, this is also equal to 1. And g1 is also equal to 1. That means this function gx is continuous at x equal to 1. Okay. Similarly at 3 you can check, 3 minus पे the limit is 1. 3 plus पे limit is equal to 1, because में 3 plus put करोगे, you will find this is equal to 1. So x is equal to 3 पे भी the function is continuous. Now if you know function is continuous, you can directly use the derivative method for checking the differentiability. So क्या करो, just differentiate this. What is g dash x? We can say this is 3x square minus 12x plus 9. Okay, what is the derivative of this? 0. This is minus 1. This is for x between 0 and 1. This is for x between 3 and 1, and this is for x between 4 and 3. Okay, so this is how, this is what we have defined. We don't have to comment on 0 and 4. You can see this is open interval 0 to 4. So we are not interested in what is the value at 0 and what is the value at 4. Now you can see I have not put equal sign here. Why I have not put? Because this is the derivative g dash x. Now we will see whether the function is differentiable at 1 or not. How will you check this? You just find what is g dash 1 plus, what is g dash 1 minus. So what is g dash 1 plus? 1 plus will be equal to 0. What is g dash 1 minus? 1 minus, you will put the value here. This is 3 minus 12 plus 9, which is equal to 0. That means the function is gx is differentiable at x equal to 1. This is one point, differentiable. Now second, we have to check the differentiability at 3 also, because function is changing its definition at 3. So this is, what is g dash 3 minus, what is g dash 3 plus. So what is g dash 3 minus? G dash 3 minus is 0. And what is g dash 3 plus? 3 plus, this is equal to minus 1, which are not equal. That means the function is non-differentiable at 3, but this is differentiable at 1, because दोनों sides से limit क्या है, same है. So you can put 1 at any point. This is the derivative function. Correct? So this function is non-differentiable at how many points? This is non-differentiable at only x equal to 3. So that is the answer, that this function is non-differentiable at only one point. At only one point, this is non-differentiable. So I hope this is clear. The important part for this question was how to define this. This is the important part. Okay. Now let's move to the next question. Now here we have some composite function. So let's solve this question. The question is, a function is defined, f is defined, g is defined. The number of points of non-differentiability of f of gx. Okay, तो आपको f of gx पे non-differentiability check करना है. So how will you check the non-differentiability of f of gx? So for that you will define f of gx. What is f of gx? F में you put gx. So if we put gx here, this is gx plus 2 when gx is less than 0. And what is this? Gx whole square, where gx is greater than or equal to 0. F में we have put gx function, right? Now how will you check gx is less than 0? और उसमें check कैसे करोगे कि we have to take this part or this part? तो उसके लिए best तरीका is draw the graph of gx. So now see, if I draw the graph of gx function, this is our x-axis, y-axis. We are trying to draw the graph of gx function. So for gx, you can see for x greater than equal to 1, this is, let's say, 1. At x equal to 1, this is equal to 1. So you can see this is 1 at x equal to 1, right? And this is a straight line with slope 3. So this is something like this. This is for x greater than equal to 1. This is 3x minus 2. Y is equal to 3x minus 2 for this, correct? Now, for x less than 1, what is the value at x equal to 1? You can see this is also equal to 1. So this will also start from 1. And this is y is equal to x cube. We know the graph of y is equal to x cube. This is something like this. Okay, this is the graph of y is equal to x cube. So this is y is equal to x cube. For x less than 1, this is the graph. Correct? So this is the graph of y is equal to gx function. Correct? Now see, we want to define f of gx. Gx is less than 0. In which interval gx is less than 0? We can see gx, that is y, is less than 0 here. That is x cube plus 2, where x is less than or equal to 0. You can see we don't want 0 here. So we will just remove this. We don't want gx to be equal to 0. So we will say this is gx for x less than 0. This is x cube. You can see gx is negative for this part. And what is this? X ka interval minus infinity to 0. So this is x less than 0. And what is this function? This is y is equal to x cube. Gx is equal to x cube. So I have just put it here. Now, ये gx less than 0 हो गया. Now gx greater than equal to 0. So it can be here. Gx मतलब y positive. So we can have this thing or we can have this thing. So what you can say is, if gx is greater than equal to 0, this will be equal to x cube. That is, this is x cube. X cube. If x is between 1 and 0. Now gx 0 कहां पर हो रहा है? X is equal to 0 पे हो रहा है, तो इसको हमने 0 equal to 0 यहाँ पे कर दिया. अब 1 पे क्या होगा? We will check. Okay. Now if x is greater than 1, we can see here, this is x is greater than 1. This is gx function क्या है? 3x minus 2. This is 3x minus 2 का square for x greater than 1. Now you can see here, clearly see here, at x equal to 1, this function is also giving you 1. This value is also giving you 1. So you can place equality at any point because at x equal to 1, दोनों से value आपको 1 ही मिल रहा है. ठीक है? So let's put it here. ठीक है? Ultimately दोनों से value 1 ही आपको मिलेगा f of gx का. ठीक है? So we have defined this function f of gx. What is f of gx? This is, you can say, x cube plus 2. X cube plus 2. This is x raised to 6. And this is 3x minus 2 whole square. Okay, this is for x less than 0. This is for x between 0 and 1, and this is for x greater than 1. So ये function आपका आ गया. This is the function f of gx. Now we have to check the points of non-differentiability. Before that, you can see this is always differentiable. This is a differentiable, different differentiable. So we have to just check the differentiability at end point. सिर्फ हमको end point पे differentiability check करना पड़ेगा. Correct? So now see, और जहाँ पे change हो रहा है definition, we have to just check this. If you just observe this function is continuous or not, उसके लिए आप क्या कर सकते हो? What is the limit x approaches 0 minus. 0 minus पे you can see this is equal to 2. 0 minus पे this is equal to 2, and 0 plus पे you can clearly see this is equal to 0. So you can see here at x equal to 0, f of gx is discontinuous. एक बार फिर चेक कर लो, 0 minus पे this is equal to 2, 0 plus पे this is equal to 0. Both are not equal. LHL and RHL at x equal to 0 are not equal. That means this is discontinuous. And if this is discontinuous, this automatically implies this is non-differentiable at x equal to 0. Okay. So one point of non-differentiability is x equal to 0. Correct. Now, if you check 1, what is limiting value at 1? You can see limit x approaches 1 minus is 1. 1 plus is also equal to 1. That means this is continuous at x equal to 1. Continuous at x equal to 1. Now see, if you want to check the differentiability at x equal to 1, what you can do is you just differentiate this. Because x is equal to 1, तो continuous है तो differentiate करके check कर लो. कैसे? What is the derivative of this? This is 6x squared. The derivative of this is 6x raised to 5. Now what is the derivative of this? This is 2 into 3x minus 2 into 3. तो मतलब क्या हो गया? 6. This is the derivative. Now 1 minus पे इसका limit क्या होगा? Derivative का. What is the limit? 1 minus, this is equal to 6. You can check this. And 1 plus पे derivative का limit क्या? देखो ध्यान से. If I put x equal to 1 plus here, this will be equal to again 6, because 6 ये बनेगा 3 minus 2, which is 1. This is also 6. मतलब इसका left hand derivative and right hand derivative at x equal to 1 are 6. Both are equal. That means this function is differentiable at continuous and differentiable at x equal to 1. Again you can check this. इसको differentiate कर दिया हमने, इसको differentiate किया, you have this. And 1 plus और 1 minus पे इसका limiting value check कर लिया, and you can clearly see this function LHD and RHD are equal. ये मतलब आप तभी लगा सकते हो जब function क्या है, continuous है. At x equal to 1 continuous था, इसलिए हमने ये apply कर दिया. ठीक है? So this is how we can solve this. So how many points of non-differentiability? We have only one point of non-differentiability, that is x equal to 0. Okay. So this is how we can solve this. So understand this, how we define the composite function, and then how we got the differentiability check. Now next question is, let f is defined from 0 to 3. P denotes all the set containing all the points 0 to 3 where f is continuous, and Q set of points containing x belongs to 0 to 3, which is non-differentiable sum of elements of P and Q. So now first see here, we have to check the continuity and differentiability of minimum of what is x minus box x? This is fractional x, and this is x minus box x, again this is 1 minus fractional x. All right, and we have to just check in the interval 0 to 3. Now see, if you just draw the graph of this minimum के लिए, we will draw the graph of fractional x, we will draw the graph of 1 minus fractional x, and उसमें जो graph नीचे की तरफ होगा, that will be the minimum. So see, we know the graph of model fractional x. This is closed interval 0 to 3. So I'm just trying to draw the graph of fractional x. Between 0 and 3. This is 1, this is 2, and this is 3. And what is this? This is 1. This is the graph of fractional x. Okay, this is the graph of fractional x between 0 and 3, 0 and 3 closed. Okay, now we have to draw the graph of 1 minus fractional x. So now see how to draw the graph of 1 minus fractional x. You can clearly see the fractional x जो होगा minus fractional x, that will be just the reflection of this. तो इसका reflection आप draw करोगे minus fractional x, उसमें +1 करोगे तो it will shift up. So can we say the graph will be something like this? Just observe this. इसको हमने नीचे रिफ्लेक्ट किया, उसके बाद 1 यूनिट हमने शिफ्ट कर दिया। तो नाउ यू सी हियर, और इस पे जो वैल्यूज होंगी वो यू कैन सी दिस इज क्लोज्ड, ठीक है। यू कैन सी जब फ्रैक्शनल एक्स 0 होगा, यू कैन सी फ्रैक्शनल एक्स 0 होगा तब ये 1 होगा, जब फ्रैक्शनल एक्स 1 होगा तो इट विल बिकम 0, फ्रैक्शनल एक्स विल बी 0, यू कैन चेक दिस इज 1, ठीक है। Now if you just observe here, what is minimum, what is the minimum of these two? So this is the graph, this is the graph of 1 minus fractional x, okay. Now see, if you draw minimum of these two, minimum that means the graph which is below. So let me plot this. This is the graph which is below. Okay. Now P denotes a set containing the function containing all the x belongs to 0 to 3 where f is OO. This should be discontinuous. It should be discontinuous. Just correct this. This is discontinuous, and Q is set of all the points where function is non-differentiable. So what are the points of discontinuity here? So the points of discontinuity, you can see between this point to this point, this is minimum, this is minimum, right? Similarly, this is minimum, and so on. So how many points of discontinuity we have? We can clearly see there is no point of discontinuity here. Why this is no point of discontinuity? There is no break in this function, right? These points will be the now. So points of discontinuity तो आपका 0 हो ही गया है. Now what are the points of non-differentiability? That is important. You can see here in Q denotes all the points in open interval 0 to 3. तो फंक्शन नॉन डिफरेंशियल आपको ओपन इंटरवल 0 और 3 पे चेक करना है, ठीक है। सो नाउ वी जस्ट ऑब्जर्व this is one point of non-differentiability, this is another point of non-differentiability, similarly this. Why these are non-differentiable points? Because these are sharp corners, 1 2 3 4 and 5. So what are the non-differentiable points? Number of non-differentiable points is equal to 5, and what are the discontinuous points? This is equal to 0. You can clearly see there is no discontinuity. Differentiability के लिए you can check this is the corner point, that's sharp corners. So these are the sharp corners. How many points? 1 2 3 4 5. We are not interested at end points, that is why this is equal to, okay. So what is the answer? P plus sum of number of elements in P plus Q, this is equal to, this is the answer for this question. So basically ये ग्राफ का ही क्वेश्चन है, इसमें आप बस कंटिन्यूटी चेक करना है, डिफरेंशिएबिलिटी चेक करना है by drawing the graph, ठीक है। So I hope this is clear. Now the last question on this, we have fx is equal to this is differentiable at every point in the domain, then what are the values of a and b? So you have to check what are the points, what are the values of a and b, so that this is differentiable. So first thing you can just define this, so it will be easy to observe this. You can see if I say x is modulus x is greater than 1, so I can have x greater than equal to 1, I can have x less than equal to minus 1. So if I say x is greater than equal to 1, this will be 1 by x only, because x is positive. If x is less than minus 1, this is equal to minus 1 by x, because x will be negative. Second, this is x is between 1 and minus 1, this is equal to ax square plus b. So this is the function we have. तो इसको हम थोड़ा सही से लिख देते हैं. This is fx is equal to minus 1 by x if x is less than equal to minus 1. If x is between 1 and minus 1, this is ax square plus b. Okay, and if x is greater than equal to 1, this is equal to 1 by x. Now we are saying that this function is a differentiable function. It is a differentiable function at every point in the domain. For differentiable, the function has to be continuous. So just make this function continuous. अब continuous के लिए क्या करोगे? -1 पे इसका लिमिट -1 प्लस पे -1 पे फंक्शन का डिफरेंशियल चेंज हो रहा है, करेक्ट? तो -1 माइनस व्हाट इज द लिमिट? -1 माइनस व्हाट इज द लिमिट? दिस इज इक्वल टू 1. -1 इसमें पुट कर दो, बिकॉज़ इसमें इंडिटरमिनेसी तो है ही नहीं, so you can see this is equal to -1 and -1 प्लस पे इसका लिमिट क्या होगा, this is equal to a plus b. -1 plus पे you can see this is a plus b, correct. Similarly, so both should be equal for the continuity at x equal to -1. Now for continuity at x equal to 1, 1 minus पे इसका वैल्यू क्या है, this is a plus b, और 1 प्लस पे इसका लिमिट क्या है, this is equal to 1. तो a plus b equal to 1 से you can see this is continuous at x equal to -1 also and continuous at x equal to +1 also. तो फर्स्ट कंडीशन क्या हो गया, a plus b should be equal to. Now what is the second, अब आपको डिफरेंशिएबल बनाना है. Now for differentiability, what you can do is you can directly differentiate this, the shortcut. If I differentiate this, because हमने continuous तो बना ही दिया है, so if you differentiate this, what is the derivative? This is 2ax, ना, correct? So now what is f dash derivative -1 minus -1 plus, this is equal to 1 and this is equal to -2a, correct? You can check this. -1 minus limit is equal to 1, -1 plus limit is equal to -2a. So what is the value of a? A is equal to -1/2. Similarly 1 minus पे इसका लिमिट क्या होगा, this is 2a and 1 plus पे इसका लिमिट क्या होगा, -1. तो a is equal to -1/2 from this also, ठीक है. So a is equal to -1/2 पुट कर दो इसके अंदर, तो what is the value of b? b is equal to 3/2. b is equal to 3/2. So -1/2 comma 3/2 is the answer, that is option 4. Just check this, ये कैलकुलेशन थोड़ा सा ध्यान से देख लो. b का डेरिवेटिव 0 होगा तो हमने वो 2ax प्लस लिख दिया था. So I hope this method is clear. मेथड क्लियर होना चाहिए. This is डेरिवेटिव हमने फाइंड किया and we got this, ठीक है. Whenever, always remember, whenever you have to check the differentiability, जहाँ पे differentiate करना easy है, तो if the function is continuous, you can directly differentiate and then check the differentiability. उसका कंडीशन आप अप्लाई करके चेक कर सकते हो, ठीक है. So I hope you have understood this question also. थोड़ा सा calculation mistake था, but you can easily understand this. So in the next video again we will solve the questions on calculus. So I'll give you questions which have appeared in 2021 in the next video in on derivatives. Okay. So that's it for now. Thank you.